Alrighty, welcome back again. This time we have one more solving problem. So remember, when we're solving rationals, we are looking for what value of x would make this statement true. So the very first thing we want to do is we want to do our restrictions. The restrictions come from the denominator. So any value of x that would make any one of these denominators equal 0 is going to be a restriction. So right off the bat, I can say x cannot equal -2. X cannot equal -5. For this one, I need to go ahead and factor this. I know a 6 goes into both 6 and 24, which gives me 6, x plus 4. So I know x cannot equal -4. Now we're ready to go ahead and start solving. In order to start solving, I need to deal with this side first. I need to get it down to one fraction. In order to do that, I need to go ahead and add, which means they need to have a common denominator. Unfortunately, x plus 2, x plus 5, they have nothing in common, so both of them need to be multiplied by each other. So I'm multiplying each fraction by the well-chosen one. The first one, got the well-chosen 1, the x plus 5 over x plus 5. The second one, got the well-chosen 1 of x plus 2 over x plus 2. So gave each other the denominators they needed in order to have a common denominator. Now we know that in order to add, you need to go ahead and fully multiply out here. When you are multiplying a binomial by a binomial, make sure you FOIL or distribute each term to each term. So x times x gives me x squared. X times -1 gives me -x. 2 times x gives me 2x. 2 times -1 gives me -2. Now that they have the same denominator, I go ahead and add. So this is a step where many people are getting lost and think the whole reason I just did this was to make sure they had a common denominator so that I can add. So I'm going to go ahead and finish adding here. We add by combining like terms. So x squared is by itself. When I look at my terms of x, I have 3x plus 2 is 5, minus 1 gives me 4. And then I have 15 minus 2, which gives me 13. This is all over x plus 5, x plus 2. Now that I've simplified this side down to 1, it's really important to remember that it was actually set equal to something. So it is set equal to 5x plus 20 over 6x plus 24. At this step, we would go ahead and try to cross multiply, or we would even see if the denominators had anything in common. But we know this one factored to 6x plus 4. So I don't have anything in common. It wouldn't make sense to try and make my denominators the same as we have in some other problems. However, as I look at this one over here, I go, this also looks like it might have an x plus 4. I know 5 goes into 24 times. So if I factor this, I get 5x plus 4. Well, if we were to get rid of what was really there, let me use a smaller eraser. So I could have rewritten it like this. When I rewrite it like this, I notice those x plus 4s cancel. And because they cancel, I can actually just go ahead and get rid of them. Meaning that this denominator, or sorry, this fraction is really just 5/6. So when we're solving, we want to get rid of as much as we can so we can go ahead and get rid of that. Now I am actually ready to go ahead and cross multiply. It's going to give me 6 times x squared plus 4x plus 13 is equal to 5 times x plus 5, x plus 2. We know that in order to solve, we need to actually multiply all this out. So I get 6x squared plus 24x plus 78 equals 5 times x squared plus 7x plus 10. I FOILed this really quickly. The shortcut, in case you're curious, because both of these had a leading coefficient of 1, I know that the two numbers add to give me my b term and multiply to give me my c term. Is that same method I would have used to factor this, I just used it to instead multiply, because we know factor and multiplication go together. I can now distribute that 5, so I have 6x squared plus 24x plus 78 equals 5x squared plus 35x plus 50. I'm so close, I'm ready to get into my solving stage. Let me write that back up here. Okay, I was double checking to make sure I had everything written correctly. So in my solving stage, anytime I see a quadratic, so squares, I know that I need to move everything over to one side. I always want my quadratic term to be positive, so I'm going to take everything on this side and move it over here because 6 is larger than 5. Alrighty, so 6x minus 5x gave me x squared. Sorry, those were squares. 24 minus 35 gave me negative 11. 78 minus 50 gave me 28. I'm ready to factor. So I'm looking for two numbers that add to give me negative 11, but multiply to give me 28. Well, as soon as I think of 28, I think of 7 and 4. I know that 7 and 4 add to give me 11, but I need negative 11. Well, negative 7 and negative 4 give me positive 28. Negative 7 plus negative 4 give me negative 11. So those are going to be my two numbers. And now we can go ahead and solve. We know that x equals 7 and x equals 4. Very last step is always go back and double check those restrictions. I'm looking for 7 or 4. I have negative 2, negative 5, negative 4. So I'm good to go. Neither of those are there, so these are my final answers. So there you have it, one more how to solve a rational equation. This one might look different from some other techniques, but this is the technique I always use. So go ahead and find those restrictions. If there's any operations you can do that operation to get that side down to one fraction. Cross multiply. Once you've cross multiplied, make sure you are actually doing the multiplication there. Go ahead and solve. And that last reminder that if when you're in the solving, you have a quadratic, you move everything over to one side, factor, solve. Check your restrictions, done.